All right, welcome to Data Math Concepts. What we're going to be looking at in this segment is stationary points, right? But before we start doing the calculations on stationary point, what we want to do is stationary points, we want to take some time just to look at what do we mean by stationary point, and, how can we actually, find the nature of those stationary points when we actually find them. Let's take a look at what do we mean by stationary points. All right, so let us say we have a certain function that looks like this, right? So that function would have, as you could see here, some local maximum and local minimums. All right, so we're looking at the fact that the graph could be decreasing or increasing all the time, except for some specific places where it's neither increasing or decreasing. So let us look at the graph that we have in front of us right now. So we're definitely seeing where this graph here would be decreasing for some point here. So decreasing would be referring to when the graph is lowering in its f of x value. In other words, the values of y are decreasing. For example, if I should be looking at the y values, the values on the y-axis, you will see that it's getting smaller until it reaches a place where it's not getting any smaller. So this would have been called a minimum, or what we call a local minimum there, because it did not get lower than that. And then if you notice, as we travel further, you would realize that the graph is increasing between A to B, between that point. So if I should be taking the y values, so between A and B, if I should be taking some y values, you would notice that the y values are getting larger. So then the graph is increasing. And it increases until it reaches a point here at B where it is at its maximum. So we call that a local maximum, right? So at B, I have a local maximum, and you'll notice that it is not increasing anymore because I'm not going further upwards, and it's not decreasing either. So that is why it is at that max. Then now to the right of it, if you notice, I will be decreasing again until I reach C. At C, I am at a local minimum again because I am at this point right here where I'm not increasing or decreasing. And then to the right of that, I'm going up again. All right. So when we talk about a stationary point, we want to locate the local maximum or minimum of the curve. Now, when we have a local maximum or minimum, one would notice that there are certain x values. So when we talk about the stationary point, we're talking about the coordinate of the point, all right, at a certain place. For example, if I was to, let us say, let me mark up this. Let us say we have a small a here, we have a small b here, a small c there, and a small d there on the x-axis. Right here at big A, we have a local minimum. So it means then for the coordinate, I would have to evaluate f of small a to get this y value here. So example, this point here, this x and this y, would come about by evaluating that A in the function to get the Y value that matches with that A. So in other words then, what are the values that we're dealing with here? The coordinate would have been that A value and the F of A that I would have evaluated here. Similarly, at B, at this point here, big B, small b would have been evaluated in the function. So would have had the F of small b, which is whatever Y value that I'm getting there. So those ideas are what we're going to be doing. When we find the X value at local max or min, we have to evaluate that in the original function to get the Y value that matches with it. Now, if you notice, at the local maximum or minimum, we are not increasing or decreasing. The idea of gradient does come in because when we are increasing, if we should find the gradient at specific points, for example, if we're supposed to find the gradient here, 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 we will definitely get a positive number all the time. But when we reach at B, we will neither get a positive or negative. It will be a 0 for our gradient. If we start to find the gradient when the curve is decreasing at all of these places, we would get a negative gradient until we reaches C, where it is a local minimum, where we will neither get a positive nor a negative because the gradient will be 0. So the idea of finding the gradient function and equate it to 0 will be what we'll be using to help ourselves as we go towards finding the stationary points. Because at the stationary points, the gradient is 0. Let's check this question out. The question says, use